Hello dear students, welcome to the series of sessions where I am discussing short tricks, alternate ideas to solve questions of various subtopics which are important for exams like JEE Advanced especially. After knowing these ideas, you will find alternate ways, you will feel more confident while solving questions in exam. In today's session, I will take linear equation in 3 variable, which we normally do with the help of determinant and matrices. But I will give you a different aspect, different way to look at these questions. Okay. Before I go further, I would like to talk about 𝒁𝒐, who got rank 15 in JEE Advanced 2025. He got full 120 marks out of 120 in JEE Advanced in maths. That's a rare feat achieved by any student across country, I can say. He was student of 𝒉𝒐𝒏𝒒𝒄 20-25. I was teaching him for 3 years. The ideas which I am sharing in these sessions are actually outcome of discussion that we used to have in his batch. In fact, some of the ideas are of 𝒁𝒐 also. Okay, dear students, I am still occupied with my batches of like 𝐒𝐴𝒂𝒂 and 𝒉𝒂𝒐. But Shimon sir suggested that I should be sharing some of my ideas, some of my ways of solving the questions with the students of his YouTube channel. So that's how these sessions started. But for me, recording this session, thinking of what is to be done, some effort is gone there. So why I am saying so, that as this is extra work for me, okay, but the response, the feedback I am getting from all of you is very encouraging, so so I feel that I should continue this session for a long time. So dear students, whatever you feel, please keep commenting, keep sending your feedback in the chat or otherwise, so that I include those things in my sessions. Okay. Before I go further, one last thing, and that is this QR code. This is for Telegram channel of 𝒂𝒂𝒂 2026. So if you are writing JEE Advanced this year, please join it. All the details regarding 𝒂𝒂𝒂 you will get there. When exam will be happening, when entry test will be happening, all these things you will be getting there. So please join it. So dear all, this is me, Surendra Jain. I am teaching maths for last 14 years. Teaching students for JEE Mains Advanced, Olympiad, CMI, ISI. So let's start. So I was talking about these 3 equations. Okay. Now, how we solve this question? I think we solve this by 2 methods. I will not teach you those 2 conventional methods. That is, 1 determinant method and 2 matrix method. In determinant method, we call it as a Cramer's rule. I will not teach you. I will just give you the reference of that method, how it is done, so that I can later compare my method with this method. In fact, sometimes these methods are also very good. I am not denying it. So you should know these methods also. Okay. So what is the determinant method? In the determinant method, we define a determinant D with the help of coefficients A1, A2, A3, B1, B2, B3 and C1, C2, C3. The coefficients of X in first column, Y in second, Z in third column. Okay. Now, if this D is not equal to 0, okay, we define 3 more determinants called as dx, dy, dz. The dx is obtained by D only. Just replace first column of D by D1, D2, D3. The first column of D is A1, A2, A3. You replace it by these D1, D2, D3 and you get dx. And similarly Y, where D1, D2, D3 will come in second column, dz, it will come in the third column. So if D is not equal to 0, you get value of X, Y and Z. For that, you need to find 4 determinants of 3 into 3 order. Okay. Similarly, if D becomes 0 and dx or dy or dz not equal to 0, you have no solution. If all 4 are 0, but with some exception, other than that exception, we have infinite solution. And that exception is if A1, A2, A3, that is coefficient of X, coefficient of Y and coefficient of Z, they all are in same ratio, but the coefficient on the right side, that is the constant term actually, they are not in the same ratio. Then you will still get d, dx, dy, dz 0, 0, 0, 0, but you will not get any solution. So that is the exception for this case. Other than that, you can definitely use if all 4 are 0, you will be getting infinite solutions. Okay, but the question is finding 4 determinant is a big task. Okay, the same method is there in matrix also. You write your equation as ax equal to b, where a is matrix formed by coefficient, x is coefficient, x is column matrix made by variables x, y, z, b is column matrix made by constant on the right hand side, and if A inverse exists, that is determinant of A is not equal to 0, then that's the formula to find x, where you need to find adjoint of A. If determinant becomes equal to 0, then you find adjoint A into B. If it is not null, then no solution. If it is null along with determinant equal to 0, then infinite solution, other than one exception, same exception that I told you in that determinant method, Cramer's rule. So then infinite solution, and in that exception you will be getting determinant A equal to 0 and adjoint of A also equal to null matrix, but you will be having no solution. I think no is hidden. You will be still having no solution. So this is how these two method works. So in two methods you can see either you have to find 4 determinant value, or in case of matrix you have to find determinant of A and also adjoint of A, where cofactors of 9 elements are to be found. Okay, so these are the available method. Now I will talk about my method. But before you understand my method, please understand, please recap or try to understand the concept of plane in 3D chapter. In 3-dimensional chapter that is there in our syllabus, there is a concept of plane, the plane. It is not there in JEE Mains anymore, but it is still there in JEE Advanced. You remember that equation of plane also looks similar to the equation in 3 variable. So I can understand this equation to be equation of a plane. Now solving these 3 is like finding common point on these 3 planes. Now if these planes are having just one common point, then unique solution. If they are having infinite points, then infinite solutions. If they are having no common point, then no solution. Okay, I will first take the case when your planes are not parallel. I will take when no planes are parallel. Okay, in this case, let me take the example of 3 planes where you are sitting in your room. One plane as this wall behind you, and one plane that is on the right hand side, and one as a roof. Now you can very easily imagine that there will be one corner where you will find that point to be lying on the 3 planes, this plane, and this plane. Okay, so if that is the case, you will be getting unique solution. Okay, so that I am not making any diagram, but suppose you are having one plane here, that is your back wall you can say, and one wall is on your right hand side. Okay, this side. So you can see there is one edge in your room. In fact, you can call this as a straight line of intersection of these 2 planes. Okay, now if I take one more plane that is passing through this line, that is the line of intersection of these plane P1 and plane P2. Okay, now you can see the 3 planes now having one infinite line common. So every point there will be solution of these 3 equations if your plane belongs to this category. So that is the case of infinite solution. Okay, now one more case remaining, that is no solution. When will it happen? For that, what I will do, I will draw 2 planes, but it is actually the cross section. So try to visualize the planes are like this, coming out of your plane or going into the plane. So these are 2 planes and their line of intersection is this. So this is the line here. Okay, now you may have a plane which intersect these 2 planes like this, so their line of intersection will also be a line going into this plane. So these 3 lines are parallel. Now if these 3 lines are parallel pairwise, so there will be no intersection point of these 3 lines. So you cannot find any point that is common to all 3 planes. So this is the case of no solution. In fact, we call this case as a prism. case of forming a prism, you can see this will be, this is just a cross section. So if you visualize in 3D, it looks like a prism. You know how prism looks like in your physics also. You have done experiment or you have seen it in optics, I think. Okay, so infinite solution case, no solution case, and unique solution case is there when you are having one wall like this, one wall like this, one roof on top of this, so one corner will be there. Okay, so now we will be finding how these cases can be identified with my method, short trick. I will not use determinant, I will not use matrix. Please see how. I have taken the case of infinite solution first. Okay, so suppose you are having three planes which are having a common line of intersection. So these three planes are like this. Okay, and common line of intersection is this, that is the cross section. So you can imagine the line going into the plane. Okay, now in the chapter 3D plane rather, okay, we study this thing that if two planes are intersecting in this line, then equation of any plane can be seen as family of plane of line of intersection of P1 and P2. So P3 would be equal to P times P1 plus Q times P2, where P, Q are some scalar quantities, some real numbers which multiplied with the equation of P1 and P2 will give you P3. In your books, you might have done this with P1 plus lambda P2. So this P is like 1. That can also be done if you divide this entire thing by P. But if you divide the entire thing by P, your equation will remain same, but your coefficient will change. But because we are given coefficient in the question itself, we cannot change it. So that's why I have kept P here. So that is also unknown for me. So one unknown is P, one unknown is Q. Now if these three planes are pertaining to this case, then two coefficients should be able to give me the third plane, which means I should be able to get 4 equations when I compare both sides for x, for y, for z, and for constant term. For x, if I compare, you will be getting P into A1 plus Q into A2, and that will be equal to A3. So that is my equation 1. I will write this way. Similarly, P into A2 plus Q into, sorry, this will be, this will be B1 here, and then Q into B2, and that will be B3 here. That is my equation 2. Similarly, P into C1 plus Q into C2, and that is equal to C3. That is my third equation. Okay, and then for right hand side, it will be P into D1 plus Q into D2, and that will be equal to D3. That is my fourth equation. Now, as we are having only two unknowns, P and Q, so two equations should be sufficient to give you P and Q. But if they are really this case, family of planes, then same P and Q should satisfy equation 3 also and 4 also. Okay, so if you solve any two of these if you solve any two of PQ, okay, if you solve any two of the equation and you get PQ and they satisfy other two equations, then it is a case of infinite solutions. That's it. There is no need for any determinant. And please understand what calculation you have to do. You have to solve two linear equations, and the solution of this you have to put in this equation and this equation, and then you will be able to conclude if it is having infinite solution. Now, if it is a case of no solution, please understand, no solution means it should be a prism. Now in this case, please understand, this is plane P1, this is plane P2, and this is plane P3. Okay, in this case also, please see, if I shift P3, let's imagine if we shift P3 so that it passes through this line of intersection. In this case, P3 will not change the coefficient of x, y, z, only change will be there in D. So this means even if the case is of no solution, let's focus on the original P3 only. Original P3 means this one. So in this case or in this case, your A3, B3, C3 are same. So what I was talking about here, Okay, so if you solve, if P and Q from, let's say, 1 and 2, it can be from 1 and 3 also, it can be from 2 and 3 also. If P and Q from 1 and 2 satisfy 3 but not 4, what does that mean? That means your plane will be such that they could have been part of same family if D was also chosen appropriately, but D is some different number. That means your case where they would have been part of a family, now that plane has shifted somewhere else and hence there is no solution. So if P and Q from first two satisfy 3 but not 4 will give you case of no solution. Okay, let me summarize what I said. Here you are having 4 equation. You get P and Q from any two of them and they satisfy other two, will give you infinite solution. But let me tell you a practical thing. It will be better we solve P and Q from from 2 equations from first 2 only, either 1 2 or 2 3 or 1 3. Let's keep it separate because this is having different meaning in other cases. So if you solve these 2 equations, get PQ, that satisfy this also, infinite solution. But if this satisfies 3 but not 4, then you are having case of no solution. Now coming to the another case, unique solution. In this case, P and Q from 1 and 2 does not satisfy 3. Okay, does not satisfy 3, and doesn't matter 4 satisfy or does not satisfy 4, it will be having a unique solution. There is no role of fourth equation in this case. If PQ from 2 equations from 1 to 3 does not satisfy the third one, it could have been 1 with 3 and then doesn't satisfy 2, that way also it will be having unique solution. That's it. Actually in this case, if it satisfies 3 also, then it will be always like your planes will be either having same line of intersection or it will be having a prism. But unique solution can never come in this case. So that's why PQ from any 2 equations from 1 to 3 does not satisfy third one, then you get unique solution case. That's it. Now I will show this in examples how you can use it. We are given set of equations and we have to find whether unique solution or not unique solution or infinite solution or no solution. So here you can see this is my one equation. Let me call this as plane P1, this as plane P2 and this is plane P3. Okay, now if I create these equations with the help of coefficient of x, so this P will be multiplied with 1, here Q will be multiplied with 2 and that should be equal to third equation 1 only. Here for y, it will be minus 1 into P minus 1 into Q here and it should be equal to minus 2. So these 2 equations, I think very easy to solve. Just add them, you get Q is equal to I think minus 1 and if you put Q here, you get P is equal to 3. Okay, so these are first 2 equations which I was talking about. Now what will be my third equation? That will come from Z. So P into 3 here and P into 3 plus Q and that should be equal to alpha. In fact, this alpha we have to find so that we get different scenarios. Now here you can see that if third equation also satisfies this solution, this means alpha will be equal to 3 into 3 9 minus 1 8. So if alpha is equal to 8, it can lead to 2 things. It can lead to 2 things, no solution or infinite solution. But alpha is not equal to 8, nothing else need to be checked. It will be having unique solution, so option B is definitely correct. Now for alpha is equal to 8, we will now check fourth equation that is coming from the coefficient on the right hand side. So 2 into P, okay, plus 4 into Q and that should be equal to 3. But if I put P is equal to 3 here, it becomes 6 If I put q is equal to minus 1, so it becomes minus 4, that is equal to 2, which is not equal to 3. That means even if these values we take as 3 and minus 1 and take alpha as 8, it will be not satisfying the fourth equation, which means no solution wala case. It will be prism. It will be prism. So no solution for alpha is equal to 8. That's it. Now one more thing I would like to tell you before I go to the next question, which is not asked here, but I like to still tell you that suppose I have to find a unique solution, how you will find it. Okay. Now for unique solution you need to have alpha not equal to 8. Okay. So what I will do, I will multiply first equation by p, which is 3 here. Okay, so 3 times p1. I will multiply second equation by q, that is minus 1, so minus p2, and then I subtract p3 from it. Okay, so if I do this thing, what will happen? Okay, so the coefficient of x will cancel because I think we obtain pq that way only, so that x becomes, equal for p3, and similarly y will also become 0, but z will not become 0. For z it will be 3 into 3, that is 9, 3 into 3, that is 9, and here it is I think minus 1, and this here it is minus alpha into z, and that will be equal to, on the right hand side I think the coefficient here is 2, so I think it is coming out to be 3, it is coming out to be 2, actually we saw it here. Let me just check. 3 into 2 6, 6 minus 4 is 2, and 2 minus 3 is minus 1. Okay, so it will be minus 1 actually, not this thing, minus 1. Okay, so just by doing it, I think you are getting z equal to minus 1 upon 8 minus alpha. Okay, so we have found z. Now what is the value of alpha? Maybe 7 or 6 or 0, whatever. You can find z directly, and if you put z here, these three equations will be just equation in x and y now, which can be solved as a linear equation, two variable. That's very simple thing, just adding or subtracting, multiplying one equation by some number will give you that value of x and y. So this is how you can find the unique solution. Let me just see. I was getting 1 upon alpha minus 8. Yeah, that's correct. So I hope you have understood how we have found unique solution, no solution, and in the case of unique solution, how unique solution is found. Okay, after putting the z in these equation, you will be getting equation in x and y. First equation, another 2x minus y equal to something. It will be some function of alpha. This will be some function of alpha. Then you can solve it to get x and y also in terms of alpha. Okay, one more question I'd like to take here. These three planes form a triangular prism. Okay, and here you can see this lambda is unknown. You have to find what value should be there for lambda. So if it is forming triangular prism, means PQ value from first two equation should satisfy 3 but not the fourth one. Okay, now please see, for first plane, that is P1, this is P2 and this is P3. I will be writing equations for coefficient of x, so that will be P plus lambda q is equal to P3, I think it is having 3, then minus P plus 3q, that will be equal to lambda, and third equation is I think P plus 2q, sorry, and this is equal to 1. Okay, so these are my three equations, 1, 2, 3. But the problem here is only one equation is without lambda. These two equations are with lambda. Okay, so what we can do, P plus q lambda is 3 minus P plus 3q is equal to lambda, and P plus 2q is equal to 1. And fourth equation we also have to check, but let us first find what will be the value of lambda, so that these three equations are satisfied. You can find these values of lambda with the help of d equal to 0 also. No doubt about that, but how I'm going to do it, please see. If I solve these two, if I add these two, I think your q is coming out to be 3 plus lambda upon 3 plus lambda. Oh, so my q is always 1. Okay, if you add these two, I think our q is always 1. That means if q is 1 and I put it here, I will be getting p to be equal to minus 1. Okay, now if P is -1, Q is 1, then from equation 1 we can find the value of lambda. Okay, so what will be that lambda? I think lambda will be equal to, if you take P is equal to -1 and Q is also equal to 1, so lambda will be equal to, I think, 4. In one case it is coming out to be 4. In this case, if I put P is equal to -1, I think it should be same, 1 plus 3 as 4 only. So we are getting lambda is equal to 4 is the solution when we want these equation to be these three equation to be consistent, means value of P, Q satisfying these two should satisfy 3 also. Okay, so for lambda is equal to 4, if I make the fourth equation on the right hand side, so right hand side means the constant term, actually they have written constant on left hand side itself, so it will be P here minus 3Q here, and that should be equal to -2 here. Now the value of P is -1, okay, the value of Q is -3, and it is not equal to -2, so you can see for lambda is equal to 4, my answer should be no solution. That is the case of prism, But one more thing I can see it here, and that is, although we got Q is equal to 1 here, but that was with the condition lambda is equal to -3. Lambda is equal to -3. What if lambda is equal to -3, and because it is given in one of the option, so we have to look at this separately. Okay, if lambda becomes equal to -3, okay, in that case I think first two equation cannot give you the value of Q. In fact, these two equation will be same. You can check P minus Q is equal to 3, and here also P minus 3Q is equal to 3. But here if you see, it is P plus 2Q is equal to 1. If you simplify them, I think the value of Q is coming out to be, if you subtract this way, it will be -2 upon 5. Yeah, I think -2 upon 5. And the value of Q from this, actually value of P, if it is -2 upon 5, so -4 upon 5 going that side, I think 9 upon 5. Let me see what I was getting there. Yeah, Q is equal to -2 by 5, P is equal to 9 by 5. Okay, now if you put these values here also, okay, here also means for coefficient term, so P 9 by 5 and minus plus 6 by 5, this becomes equal to 3, but whereas we are having it as -2 only, so this also not satisfying what we wanted. That means this will also give you no solution. So B and C both are giving you no solution case. Okay, I hope that is clear how we are finding no solution case of triangular prism. Now coming to the case when planes are parallel. In this case, what I will suggest, just visualize the things. When planes are parallel, there can be multiple scenarios. Like one case is this, where all three planes are parallel and separated from each other. So definitely you cannot have any solution here. And this can be observed directly by A1, A2, A3, B1, B2, B3, C1, C2, C3. In case you are having some unknowns, in A1, B1, C1, A2, B2, C2. Okay, in that case I will suggest try to find them with the help of D equal to 0, and then look this case with the lens of three planes, whether they are parallel or not parallel. Although this kind of case is asked rarely, but it has been asked, sometimes it has been asked, so you should consider this also. Another case could be when two planes are parallel and third plane is going that way, then also you will have no solution. Okay, another can be when all the three planes are coincident, then definitely it is just a very trivial case. All three equations are same, that means you will be having infinite point here. Here also, if two planes are coincident and third plane is going that way, then also you will get one line of intersection here, so this will also give you infinite solution. So whenever you are having two planes or all three planes are parallel, then I will say you can again look them from the lens of plane and see whether no solution, infinite solution case. Okay, in case of homogeneous case when right side is 0 0 0, I think that is same as I have already told you, but in this case you will never ever get no solution case, because x is equal to 0, y equal to 0, z equal to 0 is always a solution. In fact, fourth solution, if you remember, for d1 d2 d3 will always be satisfied, because what you will be doing, 0 into p plus 0 into q is equal to 0 actually, so this will always be satisfied. So there is no case, there is never a case when fourth equation will not be satisfied. So what can happen, the two equations getting p and q, if satisfies third one, it will be having infinite solution. If does not satisfy third one, it will be having unique solution, that is 0 0 0. That's it. Okay, I will be sharing with you my session notes, that will be there in the description link, you can go through that also. Okay, now coming to PYQ question, starting with this question of 2018. Here we are given that set S is a set of column matrices such that b1 b2 b3 are real number and system of equation has at least one solution, and then which of the following system for this b1 b2 b3 has solutions. So let us first find out what will be the condition on b1 b2 b3 if this has solution. Maybe it can have exactly one solution or infinitely many solutions. For that I will write minus p plus 2q, that is equal to 1, and second equation will be 2p minus 4q is equal to minus 2. You can check these two are actually the same equation. If you multiply it by minus 2, they become same. So my third equation, 5p plus 3q is equal to 2. Now if you solve these two, you will be getting the values of p and q as, I think p comes out to be 1 upon 13 and q comes out to be 7 upon 13. Okay, now already three equations are satisfied because these two are same and we have solved these two, so they will satisfy all three. So there is no chance it has unique solution. In fact, if it was having unique solution, then b1 b2 b3 would have been anything. There would have been no condition on b1 b2 b3. So after knowing it is having either case of no solution or infinitely many solution, but we are given at least one solution should be there. My fourth equation, that is b1 b2 b3, should satisfy this 1 upon 13 into b1 plus 7 upon 13 into b2, and that will be equal to b3. So the required condition for solutions to be there will be this thing. Okay, now based on this value we will see whether these are having solutions or not. Now for a part, if I do the calculation, let me do it here. If I do the same calculation here, so p plus 0, because here x coefficient is 0, will be equal to 1, and this 2q plus 4 is equal to 2. I think this gives you p is equal to 1 and q is equal to 0. Now if we have to do it for z, okay, it will be 3 into p plus 5, 3 into p plus 5 into q is equal to 6. But I think p is 1, q is 0, so this doesn't satisfy. If this doesn't satisfy, it means it should have unique solution only. Dear all, if you do it by d equal to 0 method or d not equal to 0 method, I think there also you just have to solve one determinant. Your value of that determinant of coefficient will be not equal to 0. You can claim that it is having unique solution. Okay, but what if d equal to 0? Then you have to go for dx, dy, dz also. But in my method, if you can see, to conclude it is having unique solution, you need only this much of calculation. Okay, now coming to b part. In the b part, we are given these three planes. If you write for this also, so p plus 5q, this p plus 5q will be minus 2, this p plus 2q will be equal to minus 1. I think these two equations are different. We can find the value of q will be, I think, minus 1 upon 3, and the value of p is also coming out to be minus 1 upon 3. Now if we write it for z, so it should be 3 into P, that is minus 1 upon 3 plus 6 into minus 1 upon 3, and that is equal to minus 3. I think this is also giving you minus 3. That means all three equations are satisfied with these values of P and Q. Now it will be either infinitely many solutions or no solutions, depend upon B1, B2, B3 satisfies this equation or not. Now B1, B2, B3, if you use it here, it will give you minus B upon 3 minus B2 upon 3 is equal to B3, which means it should have been B1 plus B2 plus 3B3, and that is equal to 0. So if your B1, B2, B3 are having this relation in this B part, then you will be having, you know, infinitely many solutions. But my earlier condition was something different. My earlier condition was this: B1 plus 7, B2 plus 13, B3. So if I choose any B1, B2, B3 satisfying it, may not satisfy this condition. In fact, if you solve these two, you may have some particular values of B1, B2, B3, but not all will satisfy this condition. So this option B is wrong. A was correct, B is wrong. Now similarly, let's come to C part. Now in C part, if I do it again, so minus P, I'm using P repeatedly. I hope that doesn't create any confusion. Minus P plus 2Q, and that will be equal to 1. And this 2P minus 4Q, minus 4Q is equal to minus 2. Okay, I think these two are same equation. If you multiply by minus 2, you get same thing. Here minus 5P plus 10Q is equal to 5. I think this is also same equation. All three equations are same. Actually, why it is happening? Because all three planes are parallel to each other. You can see minus x plus 2y minus 5z. If you divide this by minus 2, you get same thing. If you divide this by minus 1, you get same thing. So they are parallel planes actually. In fact, in this case, if I write the ratio of the coefficients of x, y and z, they are minus 1 ratio 2 ratio 1. Minus 1 ratio 2 ratio 1. Now if you want a solution to be there, it is only possible if your B1, B2, B3 are also having same ratio. In that case, all the three planes become identical and entire plane will be the solution of these three equations. But if your B1, B2, B3 are this, it may not be true for every value of B1, B2, B3 satisfying this relation. Okay, in that case, I think this may not have solution always. This may not have solution for all B1, B2, B3. So this also seems wrong. Now this D part, you can do it yourself. It is exactly similar to A. Here also you get unique solution. You just do the same calculation as we did in A. It is having unique solution. So the answer for these questions are A and D. Okay, now coming to the next question that was asked in 2021. Alpha, beta, gamma are real numbers such that system of linear equation is consistent. Consistent means unique solution or infinitely many solutions. So let us first try to find relation between alpha, beta, gamma. Here if I do the same thing, P plus 4Q will be equal to 7, 2P plus 5Q is equal to 8, and if you solve these two, we get P is equal to minus 1 and Q is equal to 2, I think. Yeah, okay. And the third equation, if you put 3 into P plus 6 into Q, that will be minus 3 plus 12. I think it is also satisfied by the same values of P and Q. That means it will be having infinitely many solutions if we want it to be consistent. And for that, this alpha, beta, gamma should have relation. You will multiply minus 1 with alpha. You will multiply 2 with beta, and that should be equal to gamma minus 1. So it becomes alpha minus 2 beta plus gamma minus 1 is equal to 0 is the relation. Okay, if we want this to be consistent. Now what are the parts? This represents the determinant of this thing, and P is the plane containing all alpha, beta, gamma. So if P is the plane containing all such alpha, beta, gamma, the equation of P should be x minus 2y plus z minus 1 is equal to 0. Okay. and d is the square of distance of the point 0, 1, 0 from the plane P. So they're asking two things, the determinant of this matrix and the value of d. So first, if I find the d, it will be square of distance of this point from this plane. So direct formula, 0 minus 2 minus 1 upon root over 1 plus 1 plus 4, so 6. I think this becomes equal to 1.5. So the answer for D will be 1.5. Now coming to this M, I think if you want to find the value of determinant of this M, you can open it directly also, but we can use one property also. Please see, because this relation is there. If you multiply this by minus beta, the column 2, and you multiply this by 1, okay, column 2 you multiply by beta, column 3 you multiply by 1 and add it to column 1. So your first element will become alpha minus 2 beta plus gamma, so it will be 1. Here it will become 0. Here also it will become 0. See, if you do not get this idea, then also it doesn't matter, because there are already so many zeros. So if you open it, you will get your expression in terms of this relation. Okay, and here it is 2, 1, 0, gamma 0, 1. Expand along first column, so it becomes equal to 1. So answer for this will be 1, for this will be 1.5. So you can see here also we could do this question that way. Otherwise dx, dy, dz you have to find. Now coming to question of 2022, here we are given p, q, r are non-zero real numbers that are respectively 10th, 100th and 1000th term of a HP. Okay, and third equation is given as qr into x plus pr into y plus pq into z. Now if I divide it by PQR, it will become x upon P plus y upon Q plus z upon R is equal to 0. And if I write 1 upon P as capital P, similarly capital Q into y plus capital R into z, PQR will be 10th, 100th and 1000th term of a AP. Okay, let's say A is first term and D is common difference of this AP, then PQR can be written in terms of A and D. Now to find solution, no solution, infinite solution, I will write the same way. This time I will use P dash, because already they have used P. So P dash plus 10 Q dash will be equal to capital P. P dash plus 100 Q dash will be equal to, sorry, this was P not R, this was P, this is Q, and P dash plus 1000 Q dash is equal to R. If you solve these two, I think we are getting, subtract it, you get 90 Q dash is equal to Q minus P. This is 10th term, this is 100th term, so that will be 90D. So Q dash is coming out to be D, and if you put it here, we will be getting P dash is equal to this capital P, I can write it as A plus 9D and minus 10D. So this becomes equal to A minus D. So the value of P dash is coming out to be A minus D and value of Q dash is coming out to be D. And you can check it satisfies this equation also, which means either there will be no solution or there will be infinitely many solution. Okay, so unique solution case is not there. In fact, there is no option which says directly unique solution. Now, if you solve for Q upon R is equal to 10, okay, I am doing it directly. It will give you A equal to D, you can check. This also give you A equal to D, whereas these two gives you A not equal to D. Now, for no solution or infinite solution, we will check with these P dash and Q dash for the coefficients on the right side, that is constant term. So P dash plus Q dash into 0 should be equal to 0. Now, if A is equal to D, then your P dash will become equal to 0. Then this equation is also satisfied. But if A is not equal to D, then P dash is not equal to 0 and this equation is not satisfied. This means for A is not equal to D, which is there in two cases, 2 and 3, you will be having no solution. So these two should be matched with S, and you can see, and these 2 and 3 are matched with this S in option number B. In fact, for option number 1 and 4, A equal to D, they should be having infinitely many solutions. So already this fourth one is also matched. But in this option B, what they have done for the first part, instead of saying infinitely many solutions, they have given one matched with Q. So here you just have to check whether it satisfies these equations or not. I think they are satisfying. You can check. X plus y plus z is equal to 1, 100x plus 10x plus 100y plus 1000z is equal to 0. I think they are satisfying. So this is correct. So B is the answer. Okay. So coming to the last question, this is of 2023. It says alpha, beta, gamma are real numbers. Consider the following system of linear equation. Match entry in list 1 to correct entries in list 2. Okay, here if I do that P Q thing once again, so P plus Q will be equal to 2. Okay, 2P plus 0, because there is no y term here, will be equal to minus 3. I think it is, yeah, minus 3. So this gives you P is equal to minus 1.5 and Q to be equal to 3.5. Let me check the calculation. Yeah, 1.5 minus and 3.5. Okay, and if we want to satisfy it for Z also, it should be minus 1.5 into 1 plus alpha into 3.5, and that should be equal to beta. Okay, for third equation. So beta will become equal to, so this beta will become equal to 1 upon 2, you can take common, 7 alpha minus 3. Okay, so this is first equation, this is second equation, this is third equation. If you want a unique solution, then third equation should not be satisfied. So wherever you are given beta is not equal to this and this, then I think these R and S will be having unique solution. I think 1. R will be mapped with 1, S will be mapped with 1. Whatever alpha or gamma is there, they will be with unique solution definitely. But they are giving some other options also. So let us first check if I can eliminate some of the options from this or not. So for R we are getting 1 here. For R they are giving 5 here. That can be the possibility. For S they are giving 4, 5, 3. Okay, so infinitely many solutions they are giving in 3. So S can definitely not with this 3. Okay, and 5, 4 are solutions, so we cannot conclude anything. So option D is eliminated as of now. Okay, now let us see if beta is equal to this thing, then there will be infinitely many solutions. Then what should be the condition on gamma? In that case, this 7 will be multiplied with P, that is minus 1.5 plus 11 into 3.5, and that should be equal to gamma. That should be equal to gamma only, yeah, that should be equal to gamma. So what is the value you are getting from this? I think gamma is coming out to be minus 21 by 2 plus 77 by 2 is equal to gamma. So this becomes 56 by 2. So gamma is equal to 28. Okay. So if we want infinitely many solutions, along with this thing, your gamma should be 28. So if this and gamma not 28, it should be having no solution. So Q should be mapped with 2. So Q mapped with 1 will be wrong. So this option is also wrong. So only A and B are remaining. Let us see if gamma is equal to 28, it is having infinitely many solutions. So with P, it should be mapped with 3. So in both of them it is mapped with 3, so it is not helping you. So the only thing that can help you now is R. You have to find the exact solution for case of R when beta is not equal to this and gamma is not equal to 28. What should be the solution? Then only we can conclude whether this is a solution or that is not a solution. So 1 minute. I think in 1 it is unique solution, 5 it is this solution. I think it is having unique solution. We just have to check whether this is a solution or not for this thing. Okay. So if this is a solution, maybe we can do it by option putting, but if we want to do it properly, let's do it properly also. So I think by option putting it is definitely possible. So for unique solution case, what I suggested, you multiply this by P, which is minus 1.5. You multiply it by q, that is 3.5, and you subtract. When you will subtract it, x term, y term will cancel, only z term will be remaining. So for z, you will be having minus 3 by 2 here, and plus 7 alpha by 2 here, and minus beta. And on the right hand side, it will become equal to, I think, minus 21 by 2 plus 77 by 2 minus gamma, and that is coming out to be, I think, 28 minus gamma. That is coming out to be 28 minus gamma. Okay, so for this part of R, for part of this R, I think your Z should be equal to 28 minus gamma upon, this will be how much? This will be 7 alpha by 2 minus beta minus 3 by 2. Okay, now I think I got one idea, because we are only stuck for R, because R they are giving gamma is not equal to 28, that means Z cannot be 0, so neither 4 or 5 can be the answer for this one. So the only answer remaining is R, that is unique solution. So this will be having 1, and for S whether it is having 4 or not, you can check, because for S gamma they have given 28, so for case of S, your Z will become equal to 0. Okay, and if Z is equal to 0, your X will become equal to 11 from that equation, and if you know Z, you know X, I think Y can also be found, and it is coming out to be minus 2. So this way this question can also be done. I hope you understand how I have done it. So my effort in this session, let me see if something is remaining. No, I think that's the same question. Yeah. Okay, this question I'm leaving. So my effort in this session was to convince you that we can do questions with the help of shortcut method. If you feel it is tricky to remember, although it should not be, because if you understand the concept of family of plane, it should not be difficult. Okay, so try to implement this method to your questions. If you feel my old method was still better, you can go with that always, but I think here calculation is slightly less. So that is all for today. Thank you so much, bachcho. Let's meet in the next class. Thank you. Bye.